So here's our first example. I'm going to go over the steps, what to do for each step, like write out the steps for you on this one. All right, so here's our problem. We're titrating a weak acid with a strong base, and here's my acid. Notice the H, and here's my base. Now the first step is to do a dilution for these problems, a little voom voom action. All right, and I'll do them one at a time. I'll start with my acid. I've got 35 milliliters. I got a 0.2 molarity. You add volumes or additives, so that's going to be 60. All right, and then that's going to be this, and then divide that by 60. I'm going to get that for my molarity. All right, and then I need to do the same thing for KOH. If you remember, KOH is 25 and 25 or 0.25. So I'll fill that out and then solve for M2. All right, and then I multiply and divide, so I get 6.25 divided by 60. That's going to give me 0.01, like that, 0.104. That's my new molarity, and then I'm going to set that up like that. I mean, you'll eventually do these like this, but that's what it would look like solved. Now, for the next step, you're going to do your stoichiometry, and you're going to use the net ionic equation for this. And it says, awesome. It should say, assume one-to-one cancellation regardless of strength. This is assume. That's awesome. All right. What this means, assume one-to-one cancellation of strength. If I have a strong acid and a weak base, just assume it's going to be a one-to-one cancellation. All right. So here is my equation, chemical equation, an acid and a base making a water and a salt. All right. What's now, to get the net ionic, I'm going to split anything that's really can dissociate. That's these two. This does not dissociate because that's my weak acid, and I get this. And you'll notice that my Ks, or my potassiums, are both on both sides, so they're going to fall out of the equation. So here is my net ionic equation. All right. And then I'm going to plug in my values from my voom voom. All right. I'm starting with this, and I don't have anything of that. This is going to react with that and take some away. And when it reacts with this, it's a one-to-one relationship, and it's going to make that in the same quantity. So then that goes like that. All right. Now this will all cancel. This will minus, and this will add up. And that's what I get. All right. Your third step, you're going to make a rice table, and then you do your Ka or Kb, depending on what you're doing. And you want to take your values from your stoichiometry. Here is where things get a little interesting. It's particularly these values. And you're going to notice this, my conjugate base in this scenario, as you'll see, will make a significant contribution to the overall pH in the end. So my rice table, you're not using the net ionic equation, you're using the equilibrium expression for your species that's left. In this case, it's the weak acid. Here it is. So now, here are my values from my stoichiometry. I'm trying to predict how much I'm going to have of this, influenced by that. So this is going to go down. They're going to go up, all right? And then I'm going to have that. Now, my equilibrium expression is this, all right? I don't put the liquid in there. So this is going to go there, that's going to go there, and that's going to be X. Now, since for both, I even dropped it right there. You neglect the X with these, okay? I'm going to get this, and I had it there. Didn't have it up there. So these are going to fall out. I'm going to multiply these two together. Get this, and then I divide by that, all right? And after that, I divide both by this, both sides by this, all right? And I'm going to get this 3.51 e to the negative ninth, or times 10 to the negative ninth. Now that's my hydroxide concentration. Now a little quick check, that means my pH is going to be 8 point something. All right. Now this is interesting because I started with an acid and I still have some acid there, but I've got so much of its conjugate base that it kind of overtakes, and I end up with a pH that's higher than 7. Now my last step is my pH or my POH calculation, depending on what I'm doing. And I got that for there's my formula, and I got that. Then I plug that into a calculator uh, for the negative log, not the natural log, for the negative log. Thank you for reminding me of that. And I get my pH of 8.45. All right. And that's how you would do it.